Markus. Are you there, Markus?
I'm here.
Perfect.
Let me share my screen as well.
Know how it works. Share your screen. I can see
That
it.
work?
Yeah, perfect. Super.
Okay.
Take it away.
I'll aim to keep within the 10 minutes.
Yes.
So for those that don't know me, my name is Markus and I represent Pandion AI. And we're a Stockholm-based startup based on the mission to secure the need for timely information. So I will focus this short time to present a little bit how we're thinking of the next generation of Earth observation system, time, and trust. So timely and accurate information is crucial for addressing global challenges. And I mean, we have seen that there's a lot of things happening that we can monitor from space to combat things such as climate change, promoting peace and justice, and managing resources effectively. And technologies like data analytics, remote sensing, artificial intelligence, Internet of Things, I mean, these are instrumental in providing timely and precise information. They're with space-derived data being particularly vital on a more global scale. And I mean, as we saw from Jacob, after downlinking and pre-processing space data gathered by satellites, we can address many of these challenges and detect events such as illegal maritime activities, track landslides, floodings, and we can study environmental and climate change. And we at Pandion, we exist to complement services such as Orbify. So while space data is very valuable for studying past events with existing solutions, detecting current events can be a bit tricky and a challenge for many organizations. So space data quickly becomes historical when we use machines on ground to generate this information. And in around a decade, will cloud infrastructure be moved up to space? So we know projects such as Starlink, which aim to provide a global broadband coverage from low Earth orbit. That's the most one that is known, I mean, in this category of missions, but many more initiatives do exist. We saw, for instance, Reorbit in Ted's presentation. And there's also many companies and actors that are enabling computation facilities and these functions in space. And space-based data centers are emerging, which enables fast information delivery. And the cost to launch infrastructure into orbit also decrease. So with compute technology advancing, we see that there's going to be a lot of things happening in this domain. And that's one of the reasons why we're doing what we're doing at Pandion AI. And I mean, of course, there are disadvantages and advantages when it comes to this approach, but most importantly would be the reduced latency due to connectivity, which can then greatly benefit since the process, since the downlinking process takes a lot of resources and more importantly, time. So this is what I wanted to get to. So time is a very important factor when it comes to using information generated from space. The value of information depends on time, and it has a high value when there's time to act upon it before gaining a more historical value. And this immediate processing in space could greatly reduce the volume of raw data that needs to be transmitted to Earth and go possibly also through nodes of a satellite constellation to the ground segment, saving time and bandwidth. And AI system on board these satellites can process a lot of raw data, capturing by sensors, given that the data is in a qualitative analysis ready state. And I trust that Lars, following me here, will mention some more about this, but to ultimately identify patterns, detect changes, and extract useful information autonomously in orbit. So getting to the AI in Pandion. So what we do is that we're putting together an AI platform where we can run our AI models on board to secure customers' need for timely information. And today we can provide global information using satellite data to anyone, governmental organizations and businesses. And here would be a picture from our MVP, which we call it, where we simulate a global customer need by checking up on already known positions of forest fires using existing satellite data to then be able to also provide information from the generated information. So here we see a little bit of outputs and some of the things that we can extract from these positions. This is something that we can put into what is called an alert. So this is what we're saying would be able to support valuable operations for our customers. And there's a lot of scalability in when we talk about how these systems can function, depending on the different users' customer cases. So our next step is to start by implementing our so-called Alertsat portal. So this would be our space to customer interface and sales channel. And this will, with existing satellite data, be able to allow users to control, order, and receive satellite information, with resolutions that would not correspond to real time. So even so, I mean, Alertsat portal stands out through user empowerment, and we believe in giving users control of the constellation, allowing them to detect and respond to current and future events, ensuring them to that they really are met when it comes to their specific needs. And that way we can be competitive and trust is built. So I'll speak a little bit more about trust, but through Alertsat portals, users can customize their own AI applications and assess service quality and choose their information delivery method to make these corrections, which are very much needed. And this is when we sort of get to trust, because the information that we use depends highly on trust. I mean, if we don't trust the information, we will never use it. And this is especially important for any form of automatic data-driven system. And information one can trust, I mean, it's nothing absolute, but it depends greatly on, of course, the use case of that information, but also on the user's subjective thinking and domain knowledge, etc. So for Pandion AI, it makes a lot of sense to give the control to the expert, the user, or the decision makers themselves, to enable them to modify the order or to modify the functionality whenever it's needed to, and then give the AI models their own corrections. So in the latter case, I mean, today we're all on varying levels using AI as agents, whether it's about empowering ourselves or to find important information on the latest financial trends or to write better emails. And I mean, given these functionalities, we can still, I mean, we do not trust it blindly. We need to make our corrections, like using our judgment or to filter it. And if we then think of, okay, so what if we could check out our own favorite AI functionality or model, and then we let it run, and then we correct it to take the best actions according to what I think is best, then we can also start trusting this AI model more and have it as an agent for us. So thereby we can then, by using this approach, start to empower the experts, the users, or the decision makers with their own global AI agent. So having that said, I mean, as you might have caught, I mentioned something about resolutions not corresponding to real time, but since our mission is to connect space data with end users, ensuring timely and actionable information, Pandion AI introduces Alertsat. So this is a satellite constellation providing real-time access to information of critical events. So Alertsat's launch aims to deliver information multiple times a day within minutes, providing actionable insights by exploring computation and communication hardware technology, where we can extract valuable information and do that without delays, with reduced latency and more frequently. And as AI on the ground and in orbit becomes more dominant, the threat landscape will evolve. therefore, we see an absolute necessity to start adopting according to the ongoing challenges and innovations in cybersecurity practices to stay ahead of potential risks. And we think this is very important. And that's also something that really is associated to trust, we believe. And so furthermore, I mean, the use of a system, the use of a system that provides data-driven information also depends highly on trust. So when it comes to the integrity of information, the greatest threat of satellite-based information is cybersecurity concerns. And that would be, I mean, such as data from satellites to the ground being intercepted by malicious actors, tampering where one manipulates or injects false data into the transmission. This could lead to, I mean, false information being sent to the end users, or things such as unauthorized access. So as the space industry evolves, cybersecurity will be a very crucial aspect to address for, I mean, ensuring the reliability and security of satellite-based AI systems. So this is something that we're working a lot on, and I mean, we can do everything from our part, ensuring that we have AI algorithms and systems that are developed with security as a priority from the outset. But we're furthermore also working together with a leader in the European cybersecurity sector for mission-critical applications. So this is a Swedish company called Clavister, where we're trying to address the intersection between Earth observation technology, cybersecurity, and space operations. And we're very excited about this project. It's a bit anticlimactic because I'm just going to mention that, and I hope that this is something that maybe I can share in the next things explore. So please keep tab on us because this is an ongoing project. So, but we think that this is very important to really emphasize when growing quickly still. And so I just wanted to give a little bit of heads up there. But anyways, we at Pandion AI see that the value of information depends highly on time, on trust, and that, I mean, the value of Earth observation are actionable alerts through user empowerment and robust data-driven systems. So, and I would also argue that I think that the future of Earth observation lies in our ability to look beyond the type of sensor, the data provider, the kind of satellite, and look deeper within the problem and see, okay, so this is what can be supported with Earth observation, and this is the impact this can have for the user and the customers, saving money or saving lives. And currently we're working on locking down contributors to our mission, where the next step would be, as mentioned, to fully deliver our services through Alertsat portal to governmental organizations and commercial companies. And as Ted showed, I mean, the money and the opportunities are on ground and not in space. So we aim to catch this and take a big chunk of both orbit infrastructure and services on ground to the ground, and do this through Alertsat portal, and then also launching Alertsat. So please don't hesitate to get in touch if you want to contribute. And I think maybe that's 10 minutes. Thank you.
Yeah, it is. Thank you so much, Markus. I have a question for you. Or
yes.
Maybe more. I think I have two. Are your customers dominated by public entities?
Right now, we don't have any paying customers, but are supported by European Space Agency and Swedish National Space Agency and Vinnova. But we're looking at, with the implementation of Alertsat portal, deliver our services to governmental organizations and companies. So that doesn't really answer your questions, but we see that we have the possibility to deliver to both entities, but there's no domination as of now. To elaborate a little bit more, I mean, we do take a small scalable slice out of basically all segments, if we're talking about conventional segments of or markets of Earth observation industry.
Great. I have another question for you, and this one I really like, because this is somebody who bluntly says that I'm completely new to this, and this is what it's all about. Edge computing is usually fast. Real-time data, very fast. But latency, can you iterate a little bit around that?
Yes, sure. So I mean, when we're looking at how the infrastructure is conventionally set up, I mean, satellites would go in orbit, collect a bunch of data. I mean, we saw that from Jacob's presentation, and then whenever reaching a ground station, they would aim to use their full bandwidth to get that down, all that big amount of data, and that takes time. It can take time to even get above a ground station if there wouldn't be in the field of view for communication services. Can even take multiple times in orbit. So, and then whenever it would get to ground, there's still also that you need to pre-process this in a good fashion to be able to have it analysis ready. And then if you are to have it analysis ready, then you also need to take all this amount of data and be able to churn that into information, possibly through systems on ground, services on ground, which do exist, or consultancy services. It really depends on what exists and how tech savvy you are. So there's a lot of latency associated to that.
Yeah. Good. Let's see if we have any more questions for you. No, I actually think that Joachim and Markus, you should actually talk to each other one day. You're in the same city. So thank you so much, Markus. We'll leave you there and look forward to see you soon again.